Hello, this is my screencast for the CA2 for spreadsheet data analytics. So let's get right into it. Maybe now, here's my report I've made, and let's go through it a bit. So for the project, it's I'm doing it along with CA2 County, who's my partner, and we're working on it together. What I've done for it, I was responsible for pretty much all of the queries in SQL. Here's an example of some of them here. I also got the data from the internet and reformat tables so it fit into SQL properly. And I was responsible for some parts in the project, such as half step 3, did step 3, then the first 2 bits. I think we both did the last bit together. Then step 4, I gone past it. I did most of that on my own, and step 5 was done by my partner. Step 6, I did most of step 6, then Matthew created the actual pie charts that you see here, and that was, I think that's it. So we'll start at the top here at step 3, and so the first bit we were asked to do was to find the maximum, mean and standard deviation by county, and that's just the table there. That's the first 2 bits here. The first one's by county, and the second one is by province. Then the third bit, we had to rank each county by their average price or mean price from the years 2015, 2016 and 2017, and we got the data from using an SQL query, and then we graphed it. So that's 2015. You see Dublin here is the largest, has the highest average house price, and it's very much the same. The counties don't change their ranking or place within the highest lowest in the 3 years that we looked at. And then the fourth part was finding the maximum mode, median, mean and standard deviation. What we did there was got the SQL query to get us the maximum, mean and standard deviation. Then I used the median and mode functions in Excel to get the median and mode for each province. And then we were asked to make histograms. We just made histograms for each 4 of them for each province, and that's them there. And you can see that the max kind of overshadowed everything, but everything's there. So then step 4, there's 3 bits to it, and we had to state the null hypothesis. The first bit was asking us to compare the average house prices by province, and that's the graph we generated there. And the null hypothesis for this one was basically that the house prices were going to vary by province, and you can see from the graph there that that's true. And then down here in Excel, using the norm_dist function, we got these probabilities of houses being sold for more than €200,000 or less than €200,000. You can see they're all different. So this proves, for the first bit of question, step 4, that the null hypothesis is true. So then the second bit, we have to see if the house prices increased from 2010 to 2017. And you can see from the graph here that they haven't, except for Leinster, where they have actually increased from 2010. Some more data here showing a house being sold for more than €200,000 as well. You can see here in Leinster, there was in 2010 there was a 60.90% chance, whereas in 2017 a 61.64% chance being sold for more than 200,000. And in Connacht's 44% in 2010, 41% in 2017, and so on for the rest of this. So the null hypothesis for that one was that sorry, I'm trying to remember. The null hypothesis was that they have increased across all the provinces. Sorry. But it's not the case. They've increased in Leinster, but not in the other provinces. So the alternate hypothesis is that exactly they've only increased in Leinster and they've decreased everywhere else since 2010. So for part 3, we got the average house prices in Dublin 10 for new and second-hand houses. And this was a bit awkward because in the actual data we have, in the Dublin 10 region, there's actually only 4 houses that are newly built, while there's 518 ones that are being sold second hand. So the data isn't great, but probably had to work with. You see from the graph here that the second hand houses are more expensive, but when we did the probabilities we found that there's actually the percentage of house costing more than €200,000 is larger than a second-hand house. So with all that in consideration, we decided that in the Dublin 10 region alone, that second-hand houses do cost more, just because there's a lot more of them. There's only 4 in Dublin 10 region, according to the data anyway, that are newly built. So just because there's more of them, there's going to be more of them that are more expensive. So we decided to deny the null hypothesis that the new houses would be more expensive, and the alternate one is that second-hand houses in the Dublin 10 region cost more. Step 5 was to see if there's any correlation between the pricing changes in Dublin and Louth, and you can see from the 2 line graphs generated here, that there isn't. There's no correlation between those 2. Then lastly, step 6. So to start, we made a scatter graph of all the house sales. You see over here 2010 to 2013ish, that they're more spread out compared to the later years, to 2014 to 2017. Afterwards we made a trend line to see what the average house price would be in June 2019. That's it there. You see it's increased a bit from 2017. Then after this we went back to Dublin. We got Dublin 10 house prices, and we got the average and standard deviation, and we started doing some calculations. Like the first one was to find what proportion of the houses would be sold for between €200,000 and €300,000, and using norm dist, we calculated to 200,000, 300,000. Then we took the biggest probability away from the smallest one, and then we got what was in between, which is we found there was 29.26% chance, using the 2017 average and standard deviation, that a house would be sold between 200 and 300 grand. Then we see, well, what's the probability of a house being sold for over €400,000, and we thought there was actually a very small chance, using the 2017 average and standard deviation. it's only 0.44% that's going to be over 400,000. And then the last thing we did was, if a real estate agent is trying to sell 10 houses in a month, what is the probability that 6 of them are going to be worth over 300,000? And we did the normal, we got the normal distribution function, for to make less than, then we from that we calculated how many would be more than 300,000, and then we did a used the binomial dist function in Excel to find the probability that what the probability would that 6 out of 10 the houses would sell for over 300 grand, and you see that it's 0% chance of it ever happening. And now here's just all the queries we use to get our actual data. That's it.